Very, very nice to see you, Pavan. How you doing?
See you. Doing well. How are you?
Great, great, great. So what are we going to hear about today?
Today I'll be talking about an open source project called Kanister, and I can show how it can be used to do some data level, application level data operations on Kubernetes.
Perfect. All right, folks. Well, as usual, remember we can continue the conversation in Slack. Feel free to leave comments and questions as well in the YouTube comments. Also follow us on Twitter. Smash that subscribe button on YouTube. It's all yours, Pavan. You can take it away from here.
Thanks, Bart. So a little bit about myself. I am Pavan Navarathna. I am a member of technical staff here at Kasten by Veeam. For the past 3.5 to 4 years, my focus has been mostly on solving day-to data management problems for stateful workloads on Kubernetes. I've also been actively contributing to open source projects, and Kanister is one of them. I'll be covering that in our session today. So before we talk about Kanister, let's talk about data management on Kubernetes in general. Once all the infra and storage related problems have been solved, day two services like backup, disaster recovery, and application mobility take precedence. So, based on our learnings here at Kasten, we have seen that there can be multiple flavors of data management. Storage centric snapshots that mostly utilize the underlying storage provider's snapshot capabilities. In most cases, these are crash consistent and they provide pretty good way to storage the underlying volumes. Snapshot the underlying volumes. Now, one thing we know from this is that the storage-centric approach, the snapshots or the process doesn't really interact with the application itself. So the second approach here is that you could have the storage-centric snapshots, but have hooks or APIs provided by these data services to freeze and unfreeze the application during the process. So there's also the data-centric approach where you could utilize the tools provided by databases like MySQL dump and pgdump. These are capabilities by the database itself. All the compression, encryption, everything is provided by the tool. And in most cases, the recovery process is kind of complex for this. And finally, we have application-centric approach. This is more of a logical way to provide a way to execute all these different kinds of data management in a coordinated manner. Let's go to the next slide. Actually, we have to go to the slides, back to the slides, please. Yeah, thank you. Okay, so for each of the data management approaches that I talked about, there could be its own pros and cons. In terms of speed, consistency, and cost, each of them have different pros and cons. So the optimal strategy for your organization or your application would depend on the capabilities that are available on your infrastructure, as well as the needs of the application you're deploying. So cloud native applications in general, they use different components, right? They could use different data services, or they could use different storage technologies in the same application. So each of these components can have different domain experts, the Kubernetes administrator, and then you have the app developer itself. And if you are using any databases, then you have database administrators. And all these experts have their own requirements for data protection, and it's pretty difficult to separate these concerns. Then we have different infrastructure moving parts. You would have to select different types of backups, whether it's logical volume snapshots or even provider specific like Amazon RDS. And some applications require scaling up and scaling down during this snapshot process. Then once the snapshots are taken, you need a destination for these snapshots. You either move them out to an object store or even NFS or a file storage. So a good data management approach would have to be able to provide a way to coordinate among all these things and implement these complex workflows. So that's where Kanister comes in. We built Kanister to address some of these concerns. It's an open source project which is purpose built for Kubernetes and stateful workloads on Kubernetes. So all these database specific workflows can be captured in custom resources called blueprints. And these blueprints can be easily extended and shared between different experts. And basically, we provide a standardized API, Kubernetes API to execute these workflows. So what is Kanister made up of? It has four main components, the Kanister controller, blueprints, action sets, and profiles. Controller is an operator based on Kubernetes operator pattern. It's responsible for the state management of blueprints, action sets, and profiles. Now, like I said, the blueprints are custom resources used to define workflows for backup, restore, or even delete operations. Once these operations have been defined, we can use an action set to execute a particular action from a particular blueprint. Then finally, we can use the profiles to determine the destination for these backups, or in case of restore, they would be the source. There are also a couple of tools that Kanister provides, that is CanCuttle and CanDo. The CanCuttle can be used to create action sets and profiles. And CanDo is a tool that is used in the container to move data to and from the object store. As I described earlier, uh, a blueprint can be used to define the workflows for different operations. So let's look at an example here. This blueprint is a CR for, let's say, a MongoDB backup. It this The workflows are generally executed using actions, and each action has one or more phases. And here in this example, we see a backup action and a single phase where we are using a function called kubetask. This is nothing but a Kanister function where you could either have a shell script running as a command, or you could even create volume snapshots using these functions. I'll talk about the functions at the end, but that is a Kanister function. And we also have output artifacts that those are basically used to capture state between phases. So from this scoop task phase, I'm capturing the S3 path here. So moving on, once these blueprints are defined, we'll see action sets. And this action set is selecting the backup action from the blueprint we just saw. It's also selecting an object as the target for this action, that is the MongoDB replica set. And then we have a profile called example profile that is used for the destination for this backup. And once the backup is done, the Kanister controller actually sets the status of the action set. It could either be the artifacts like we see here, or while the execution is happening, it constantly updates the progress of the action itself. Finally, we have the profile. We saw that it selects the destination, and but we didn't see how it does that. So a profile contains a location that could be of S3 compliant type, or it could also be Google or Azure Blob Storage. Now here we are selecting an S3 compliant bucket called Kanister Backup, and it also has the credentials for that location. So now that we have seen like all the components, let's see how it behaves. Let's see. So assume that you have a Kanister controller, a blueprint, and a database workload. How do we back this up? So the first step would be to create an action set. And once the action set is created, the controller goes and discovers the blueprint referred to in the action set, gets the action or the definition of that action, and then interacts with the database workload using a Kanister function. If we use a kube task, it is going to spin up a pod, and that pod is going to connect to this database workload and then execute whatever command we have provided. And once the backup is complete, it can move the data to an object store, and that is selected by the profile. So after all these actions are executed, the controller is going to update the action set and update its status to complete. So now, in theory, we have actually seen how Kanister behaves. Let's see a live demo to see how we can use Kanister to back up a MongoDB replica set. So I think I'm just showing the namespace where I have the MongoDB replica set deployed on this cluster. It's a GKE cluster with Kubernetes 121 version. So we have that stateful set running. I think we'll check the pods. So we have 2 pods running. So now that we have the Mongo deployed here, let's try to add some data into it. I'm executing and going into the container there and adding some data. So it's just adding a simple restaurants table with 4 entries here, 4 different restaurants. If you have ever been in the Bay Area, you'd be um, familiar with these restaurants. So it's added 4 entries. We are just verifying that it's added 4 entries. Yes, there are 4. So what we can do now is see how we can use Kanister to protect this MongoDB replica set. So I'm going to actually check whether Kanister has been added to my Helm charts. It provides a Helm chart, so it's pretty easy and simple to deploy. So let's go ahead and create the namespace for Kanister. I think I took a while to copy the Helm command there, but yeah, just installing the 068.0 version of Kanister. Yep, the operator has been installed. Let's go ahead and verify that. Yeah, the controller or the operator is running right now. So let's go ahead and install the tools that are required to uh, create and execute some of these operations. So there's an easy script available to install can, cuttle, and can do. Let's actually skip ahead to minute 3 and 18 seconds. I think the download of this took a while. So now that we have the tools, let's just verify if the tool was installed. It should be of version 68. Yes. So there's also another step where we need a destination for these backups. So let's go ahead and create a profile. And we use can-cuttle for this, where we provide a type of the profile and then the bucket name along with the credentials we need to use for that. So we see that there is a secret created for the credentials and the profile also created here. So this is all happening in the Kanister namespace. So the last step here to protect the MongoDB is the blueprint itself. So let's go ahead and deploy the blueprint. I'm using the latest version that is available in the upstream Kanister repository. So the blueprint should be deployed. It's all you can always use kube control commands to get these CRs. So just to verify what is in this blueprint, we see that there are three different actions here. First one being the backup, and it has output artifacts where we are storing the location to that uh, the file that we create for the backup. Then we have the phases where we are using a kube task canister function, and it's actually executing a mongo dump command there. And finally, using can do to push that mongo dump data into an S3 bucket. The phase itself is called take consistent backup. We can also pass objects into phases, and here we are actually providing the Mongo secret with the Mongo DB credentials. So if we see here, the delete operation actually has an input artifact, which is nothing but our output cloud object that we created, so that the delete action can then go ahead and delete that file from the S3 location. Again, we are using a kube task here. And then finally, the restore action itself, again using the input artifact, and it's just doing a Mongo restore. And the data is first pulled using can do location pull. That is another command that is provided. And finally, we use that data to do a Mongo restore. This is all done again in a kube task. So again, a blueprint is any other, like any other CR, it has the metadata section with name and namespace. So everything is set up now. Let's just go ahead and create an action set to run the backup action. I'm actually taking the profile that we just created. So we just provide the type of action, the subject for the action, that is the Mongo stateful set, and then the blueprint from which the action has to be run. So the action set has been created. Let's go and check the status of that. So the phase take consistent backup is currently running. Let's give it a few seconds and check again. So we now see that the state is marked as complete. So we see a database, the S3 paths stored there, and it was using the stateful set as the subject there. Now that the backup is complete, let's just verify that the S3 has that particular file, the S3 bucket. So I'm just running S3 ls on that. So we see that file was created. I just recorded this yesterday, so the timing shows last night. So the file is there. Now what we can do is just imitate or simulate a scenario where we delete the database or the tables, and then see how we can restore that quickly. So I just dropped the table here. We'll verify that it's actually dropped. Okay, there's no entries right now. So let's go ahead and recover that using Kanister. What I'll do now is create an action set again using the backup action set that we just performed. Um the CanCuttle can be used again to do that, and we'll just provide the input action so that it takes all the artifacts from the previous run and creates an action set for restore. So there's a from flag here, which will actually do that for us. Again, we can go and check the status here by doing describe. So this has already completed before we check the status. So again, we can verify that it's running the restore action from the Mongo blueprint, and the subject is the stateful set, and all the things are complete. Like I mentioned, the events are actually noted at every point of the action execution. So it gives us an idea in case the data is quite large. It may take up a few minutes to run. We'll know that at every point what the status of that action is. Again, let's go ahead and verify that the entries are back. Yep, we see the entries again. So that was a simple backup and restore that we saw using Kanister. I had dropped the tables and and finally recovered that using Kanister. We can go back to the slides actually. Thank you. So that was a pretty simple demo. We saw that we used kubetask Kanister function there, but that's not just the only function that is available. There are many other functions in Kanister as well. I have listed a few here, but due to lack of time, I think I'll just skip explaining each and every one of them. But feel free to reach out. Would be happy to give more details on each of these functions that are available. Now, there's also some new things coming up. I'm pretty excited to talk about those. We are planning to add a guide for writing blueprints. So in case you are using a different database that we don't already have a blueprint for, this guide should help you write your own blueprints. Uh, yeah, feel free to reach out to us and we can work on a blueprint together. There's also a plan to add file storage as destination for backups. And we saw that Candu actually moved all the backup data into S3 storage, right? So uh, it we don't know how small or how big the data is. So we are planning to add like encryption, compression, and deduplication for the data that is being moved. So in case of large database dumps, we can pretty much use all these features to easily save some storage on either S3 or our file storage. Then finally, we have seen a lot of data services come up these days with operators. So that is also in our roadmap to add functions to help back up these operators. So finally, just to wrap up, feel free to reach out to us, try out the project yourself. Like you see here, a small snippet of how easy it is to deploy Kanister as a developer or in using the code itself, and run a tutorial of a Mongo blueprint and Mongo backup and restore. So I've added all the links here, the Twitter handle and the Slack channel as well. Join us. Feel free to try the project, recommend changes, and even come up with your own blueprints. Yeah, if you are in LA, do come and visit our Caston booth. I'll be here in person to talk to you about Kanister. Thank you.